Hello everyone, welcome to Math Advice. In this video, I am going to explain how to calculate Spearman's rank correlation coefficient when equal ranks are given. That is, if there is a tie between the ranks, how to calculate rank correlation coefficient. That is what we are going to discuss now. Suppose if the ranks are given, you know already you have to calculate the difference between the ranks and calculate rank correlation coefficient. Instead of ranks, if the values are given, we must give them the rank and calculate the rank correlation coefficient. This was the two cases we have discussed already. Now we are in the third ranks. So if the given values are repeated, then that problem is under the case of tied ranks. If any value is repeated 2 times, 3 times or 4 times like this, then this is a problem under tied rank. So how to resolve the tie between the rankers? You have to give the average rank between the two ranks. So by assigning the average rank, you have to break up the tie between the ranks and you have to proceed as usual. For example, let me take 70, 60, 60, 40. Now I am going to, here the values are given instead of ranks. Now first I am going to assign them the rank. For that I am going to give rank 1 to the highest value. Here the highest value is 70. I am going to give rank 1 to 70. And the next rank is for 60 because 60 is the highest value here. But here 60 is repeated 2 times. So there is a tie between the rank second and third rank. So there is a tie between the two ranks 2 and 3. So how to resolve this is you have to add these terms. That is you have to take average. That is adding 2 plus 3 and divide this by 2. You get 5 by 2. That is 2.5. So you have to assign 2.5 to 60 in both the cases. This is how you have to resolve the tie between the ranks occur. Next, I am going to assign the rank 4 because already we have to take second and third rank. So the next rank is for 4. So now you got a clear idea about how to break up the tie between the ranks. So whenever there is a tie, so you have to take the average between the ranks and give the average value in both the cases. So whenever there is a tie occur, so you have to add a correction factor. You know the formula for calculating Spearman's rank correlation coefficient, isn't it? Rho is equal to 1 minus 6 sigma d square over n product n square minus 1. So this is the formula we have used to calculate Spearman's rank correlation coefficient. So in case of tied rank, you have to add the correction factor, that is m square minus 1 over 12 to sigma d square. So this correction factor is to be added with sigma d square whenever a particular value is repeated. Here the correction factor m square minus 1 over 12 is to be added to sigma d square once to get the appropriate form of Spearman's formula. Here the m denotes how many number of times a particular value is repeated. Why we add this correction factor is because the Spearman's formula is based on the assumption that assigning different ranks to different individuals, so its correction becomes necessary in case of tied ranks. That's why we have to add this correction factor to sigma d square whenever there is a tie between the rank. Here m denote the number of times a particular value is repeated. So look at in the previous example, the value 60 is repeated 2 times. So here m takes the value 2. So here m denotes, once again repeat, m denotes how many number of times a particular value is repeated. So here m takes the value 2 because the value 60 repeated 2 times. So the process has to be carried out till to the end of giving the ranks to both the series x and y. So we make use of the formula rho is equal to 1 minus 6 sigma d square plus m square minus 1 over 12 plus m product m square minus 1 over 12 plus etc. over n product n square minus 1. Here this correction factor is to be added based on this correction, how many number of correction factor we are going to add. that is based on the given problem itself. Either only one value is repeated or two value or three values repeated. So based on the given problem, we have to decide how many number of correction factor is to be added with sigma d square. As usual, here n represents the number of pairs of observations and d is the difference in ranks between the paired items, and m denotes the number of times a particular value is repeated, and the correction factor m square minus 1 over 12 is to be added for each repeated value in both the series x and y. With this short introduction, let me now move on to an example. Calculate Spearman's coefficient of rank correlation. Here the values of x and y are given. X takes a value 50, 70, 84, 96, 98, 61, 70, 97 and 92. In corresponding values of y are 60, 60, 97, 90, 88, 55, 92, 60 and 90. Look at here. In the value of x, the value 70 is repeated 2 times. And in the given values of y, the 60 is repeated 3 times and also the 90 also repeated 2 times. So we have to use the formula rho is equal to 1 minus 6 sigma d square plus m square minus 1 over 12 plus m square minus 1 over 12 plus etc. over n product n square minus 1. So you know already n denotes number of pairs of observation. So here we have totally 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally we are having 9 pairs of observation. D is the difference in ranks between paired items. So this is calculated after assigning ranks, and n denote the number of times a particular value is repeated, and we have to add this correction factor whenever a value is repeated. For that, now let me construct a table. Whereas the first and third column consist of the given values of x and y, and first what we are going to do is we are going to assign them the rank for x and y. Here R1 and R2 denote the rank of x and y. Now we are going to assign them the rank first. For that, let me give rank 1 to the highest value. Look at the values of x. Here the highest value is 98. I am going to assign rank 1 to 98. And the next highest value is 97. So I am going to assign 2 to 97. And the next highest value is 96. So rank 3 is for 96. And the next highest value is 92. So assign rank 4. And the next highest value is 84. So assign 5 for 84. And the next highest value is 70. Look at here, the value 70 is repeated 2 times. So there is a tie between the ranks. Already we have assigned up to 5th rank. So there is a tie between the ranks 6 and 7. So add 6 and 7 and divide this by 2. So to break up the tie, we have to take the average of ranks. So 6 plus 7 is 13 by 2, that is 6.5. So I am going to assign the rank 6.5 to 70 in both the cases here. So you know already the Spearman's formula for calculating rank correlation coefficient is rho is equal to 1 minus 6 sigma d square over n product n square minus 1. Whenever a value is repeated, immediately you have to add the correction factor to the sigma d square, that is m square minus 1 over 12. Here 6 and 7, that is the tie between the 6th and 7th rank, that is the value 70 is repeated 2 times. So m takes the value 2 here. M takes the value 2 here. Now we are going to assign the next rank. So 8th rank is for 61 and 9th rank is for 50. Similarly, we are going to assign the ranks for y2. Look at the values of y. Here the highest value is 97. I am going to assign rank 1 to 97. The next highest value is 92. Assign rank to 92. And the next highest value is 90. The value 90 is repeated 2 times. So there is a tie between the rank. Already we assign up to the second rank. So there is a tie between the rank 3 and 4. So you have to take the average of these two, that is 3 plus 4 over 2, that is 7 by 2. You get the value 3.5. So now I am going to assign 3.5 to 90. Here the value 90 is repeated 2 times. So m takes the value 2. So again you have to add one more correction factor, m square minus 1 over 12 to sigma t square. In this case m takes the value 2. Next we are going to assign the rank next. Next highest value is 88. So we are going to assign the next rank 5th rank. So 88 and 6th rank here. Look at here, the value 60 is repeated 3 times. So there is a tie between the rank. Already we have assigned up to 5th rank. So there is a tie between the rank 6, 7 and 8. So you have to add all these values and divide this by 3. When you add all these values, you get 6 plus 7, 13 plus 8, 21 over 3, that is 7. So you are going to assign rank 7 to 60. So to break up the tie. So here m takes the value 3. Since the value 60 is repeated 3 times, so again you have to add one more correction factor, m square minus 1 over 12. So here m takes the value 3. And next we are going to assign the next rank. Already we have to take up to 8th rank. So the 9th rank is for 55. So now the rank is assigned to all the values. Let me now calculate the difference between the ranks. That is D. So 9 minus 7, that is 2. 6.5 minus 7, that is minus 0.5. 5 minus 1 is 4. 3 minus 3.5, that is minus 0.5. 1 minus 5, that is minus 4. 8 minus 9, that is 1. 6.5 minus 2, that is 4.5. 2 minus 7, that is minus 5. 4 minus 3.5, that is 0.5. And squaring all these values of D, we get 2 square is 4, 0.5, that is minus 0.5 square is 0.25, 4 square is 16, minus 0.5 square is again 0.25, 4 square is 16, 1 square is 1, 4.5 square is 20.25, 5 square is 25 and minus 0.5 square is 0.25. By adding all these values you get sigma d square. Now adding all these values we get 4 plus 0.25 plus 16 plus 0.25 plus 16 plus 1 plus 20.25 plus 25 plus 0.25, you get the total as 83. So now we calculated value of sigma d square as 83 and substitute the values in the given formula, you get the value of rank correlation coefficient rho. Now we calculate the value of rho by substituting all the values. 1 minus 6 sigma d square is 83 plus m. Here the first value of m is 2. 2 square minus 1 over 12. Since the value 70 is repeated in Exodus, we take the value of m as 2 because m here represents number of times a particular value is repeated. How many number of times a particular value is repeated? 70 repeated 2 times, so we have to substitute m is equal to 2 here plus m square minus 1. Here itself 90 in y series In y it is 90 repeated 2 times. So we have to take m is equal to 2 here. 2 square minus 1 over 12 plus 60 repeated 3 times. So m takes the value 3. 3 square minus 1 over 12 whole divided by n square minus 1. N is number of paired observations. So totally we have given 9. So 9 product 9 square minus 1. So in case of repeated ranks, the number of correction factor is to be added is decided. That is based on the given problem itself. We have to decide how many number of correction factor is added with sigma d square. So in our problem, we have to add totally 1, 2, 3, 3 correction factors. Here the value 70 is repeated. So here we have to add 1 correction factor and taking m value is equal to 2. And in y series the value 90 is repeated. So by taking m is equal to 2 and add the correction factor, and value 60 is repeated 3 times, so we have to add 1 more correction factor by taking m is equal to 3. So here totally we have to add 3 correction factors to sigma d square. So the number of correction factor, how many number of factors is to be added with the given d square, sigma d square is to be, that is based on the given problem itself. So by simplifying we get rho is equal to 1 minus 6 83 plus 2 square is 4, 4 minus 1 3, 3 2s are 6, 6 by 12 you get 0.5. So 0.5 plus again the same ratio here itself we have, so 0.5. Here 3 square minus 1 over 12, 3 product. Here 3 square is 9 minus 1 8, 8 3s are 24 and divide this by 12 you get 2. Whole divided by 9 product 9 square minus 1, 9 square is 81 minus 1 is 80. When you multiply 80 with 9 you get 720. So 1 minus, by adding all these values you get 83 plus 0.5 plus 0.5 plus 2, you get the value 86. And you multiply with 6, you get 516 and you divide this by 720, you get 0.7166 etc. You have to take up to 4 decimal places, so 0.7167. So you subtract, that is 1 minus 0.7167. You get the value, 1 minus 0.7167, you get 0.2833. So you get the value of rho as 0.28. So the rank correlation coefficient between the two variables x and y, here you have calculated as 0.28. So based on this value, our interpretation is there is a low positive correlation between the two variables. So there exists a low positive correlation between the two variables x and y. Now to get a clear understanding about this, let me show you a scatter diagram of the two variables x and y, that is two variables r1 and r2. So here, look at here, there is an upward movement, so there exists a positive correlation. So look, all the points scattered much away from the line, so there is a low positive correlation exists between the two variables. Hope you got a clear idea about how to calculate Spearman's rank correlation coefficient when equal ranks are given. Thanks for watching. See you again in my next video.